Greetings everyone. Today we're going to explore solving a quadratic inequality. Make sure you have the note sheet ready. First, let's quickly review solving a linear inequality. Remember when solving a linear inequality, you set two inequalities up. The first one as is. The second one, you make the function, or the longer side, opposite. It's almost like we're distributing a negative in. The sign and the solution stay the same. Now, as we solve these, we're going to arrive at two inequalities. Remember, we're dividing by a negative, so I do have to flip the sign, and having a fraction can happen. We've got a negative 9/2. Now, I encouraged you in this lesson to think about where these occur on the number line. So negative 9/2 and 2 would look like this. If I'm saying my values are greater than 2, that means I'm going this direction. I'm including these solutions. And if I'm less than negative 9/2, I'm going this direction. By creating that visual, it allows us to create our interval notation correctly because we're either going to have one or two solutions, or excuse me, two solution intervals when we're solving a linear inequality. Now for solving a quadratic inequality, it's going to be a little more involved. So I do have some steps for you to jot down. The first step, you want to write the original inequality as an equation. That's just going to help us with step 2, where we're going to set equal to 0, factor, and solve. We already know how to do that, so that's why we want to make it an equation. Step 3, you're going to plot those solution values, those points on a number line. But now to see and connect it back to being an inequality, we're going to choose test points in each of those intervals on the number line to see which test points are true. If the test point is true, that's going to create our interval that is a solution. Make sure to pause here if you are still writing down. All right, let's jump into the first example. So we're temporarily going to imagine that this is an equation. By making it an equation, we can do what we've already been doing this unit. Move everything to one side, make sure it's equal to 0. We always want to check for a GCF first. In this case, I don't have one. We then want to factor. Now I have 3 terms, so I'm going to use trinomial factoring. Factors of 8, 1 and 8, 2 and 4. Factors of 4, 1 and 4, or 2 and 2. Some guess and check's going to happen. I'm going to start with 2 and 2, and I'm going to try 1 and 8. Now if I think about that, look at my b value. My b value is large, it's 33. I can't get to 33 with the smaller numbers. And now I can see that. So I'm actually going to try instead the 4 and 1, and I want that 4 to be multiplied by the 8. 4 times 8 is 32, and 1 times 1 is 1. That would get me to 33. Now, if they're going to multiply to be positive but add to be negative, they need to both be negative. Let's solve each of these just as we've done before. If I take each factor, set it equal to 0, and solve, I'd add 1 and divide by 4, so that would give me 1/4. And I would add 8 over, which would get me to just 8. Those are all the steps we know how to do. So now let's jump into what I actually need. So I'm going to keep this 1/4 off to the side. I want to write a little bigger here. And I want to keep this 8. Think of a number line. Even though there's a fraction, it's not a big deal. If I draw a little sketch of a number line, we've got 1/4 and we have 8. I just created 3 intervals. I have this interval here in red, I have this interval here in green, and I have this interval over here in blue. We want to pick a test point in each interval, and you can pick any number you want, but I would pick the easiest number to check. So for example, a number that is less than a fourth, well, I'm going to pick 0. A number that's greater than a fourth, I'm going to pick 1. And a number that's larger than 8, I'm just going to pick 10. We want to take each of those test numbers and plug them back into the original inequality. So I'm going to replace my x's with a 0 for the first one. I'm going to replace my x's with a 1 and solve. And I'm going to replace my x's with a 10 and solve. And my goal is to see which one of those ends up being a true statement. So I like to set up first, and then let's calculate. Well, the first one ends up being pretty easy. That's 0, that's 0. Is 8 less than or equal to 0? It's not. So we want to cross off that interval. That's not good. Let's check 1. 1 squared is 1. 1 times 4 is 4. 4 plus 8 is 12. Is 12 less than or equal to 33? Yes, that's good. That means my middle interval is true. Let's check the last one. 10 squared is 100. 100 times 4 is 400. 400 plus 8 is 408. 33 times 10 is 330. That is a false statement. That means that is not a set of solutions. Now I have the interval between 1/4 and 8. That means every value within that interval would make my inequality true. So for my final answer, I want to write in interval notation the interval from 1/4 to 8. On each side, we're going to have a bracket. Do you remember why? It's or equals to. Because it's or equals to, that means I can include that exact value. Now let's just acknowledge the pattern here. We had a pattern on my number line of no, yes, no. You're going to keep an eye out for this pattern on the rest of the examples. Let's jump to example 2. First, we want to do regular old quadratic work. So I'm going to try to fit this on one slide this time. Let's fit this over here. So 5x squared minus 27x plus 10 equals 0. No GCF, regular try factoring. It's going to be x minus again. I need to get to 27. So I'm actually going to try 5 and 1 and 2 and 5. So I'm just predicting that 27 is a large b value, so I want to use the largest factors. So that would give me a 25 and a 2. Perfect, I got a 27. That means if I solve each of these little guys, I would have 2/5 and I would have 5. Make sure that you create a test interval. In that test interval, 2/5 would be on the left side, 5 would be on the right. And I'm going to create 3 test numbers. Let's see, I'm going to pick 0 for this one because that's less than 2/5. For my green interval, let's see, I'm going to pick 1 again because that would be between 2/5 and 5. And my blue interval, I'm actually going to pick 10 again. I just feel like it's easier to multiply. So again, you can pick any number, but try to pick what's easiest for you. Let's test all 3 in the original inequality. So I'm actually going to set it up 3 times. All right, let's start with the red. That'd be a 0. 0 squared, 0. 0 times 5 plus 10 would be 10. This would be 0. Is 10 greater than 0? Yes, that's good. That means this interval is correct. Let's try green. We're going to plug in 1. If I plug in 1, 1 squared is 1 times 5, 5. 5 plus 10, 15. Is 15 greater than 27? No. That means this interval is a no-go. Let's try blue. We're going to try my test point of 10. 10 squared, 100 times 5, 500. 500 plus 10, 510. And 270. See how it's just easier since I knew I was going to be multiplying? Is 510 greater than 270? Yes. Let's write our final answer in interval notation. In interval notation, I exist. Well, I'm going forever in that direction, so negative infinity all the way to 2/5. Now, 2/5 is going to have a parenthesis because it's just greater than. That's how you determine that. I also have the interval of, oops, sorry, I'm not sure what's going on with my pen there. Let me fix that. My interval from 5 to infinity because I'm going forever to the right, all the values greater than 5. Again, parentheses all the way around. All right, let's try one more. We got a lot going on here. First, we want to start with the basic Algebra 1 level stuff. I see that I have x plus 3 twice, so I'm just going to write it out. I have equals temporarily, and then I'm going to distribute that 2 right away. See what I did there? And then I'm going to FOIL out that left side. You cannot distribute the square. Don't do it. Now that I have all nice terms, I'm going to kick everything to the right side. So I'm going to subtract 1x to the right. I'm going to subtract 6x to the right. I'm going to subtract 9 to the right. So what looked really messy wasn't too crazy in the end. So if I factor that, nice leading coefficient of 1, which means 5 and 1, and we've got minus minus, which means the numbers I'm dealing with are 1 and 5. Even easier, there's no fractions, so let's set our intervals here. For my test number in the red, I'm going to pick 0. For my test number in the green, I'm going to pick 2. And for my test interval in the blue, looking at that original inequality, I'm just going to pick 6. The 10 wouldn't be as helpful on this one. All right, let's set up our 3 inequalities that we're going to test. I'm going to start with red, 0. Now be careful how you go about simplifying this, right? Parentheses first, 0 plus 3, 3, 3 squared, 9. 0 squared, 0. 0 plus 7, 7. 2 times 7, 14. Is 9 greater than 14? Is not, so that's a no-go. Let's try plugging in 2 this time. If I plug in 2, 2 plus 3 is 5. 5 squared, 25. 2 squared is 4. 4 plus 7, 11. 2 times 11, 22. Is 25 greater than 22? Yep, looks good. Let's try one more. All right, this time we're plugging in 6. 6 plus 3 is 9. 9 squared, 81. And if I make a little error, don't mind me. 6 squared, 36. We have 36 plus 7, which is 43. And then 43 times 2 gets me to 86. Is 81 greater than 86? Nope, it is not. So that blue interval is a no-go. So let's talk about our final interval of solutions. From 1 to 5 with brackets. Brackets because there's an or equals to. Now let's recall the patterns. Our first one was no, yes, no. Our second one was yes, no, yes. Our third one is no, yes, no. Most of the time, not always, but most of the time you can rely on that pattern. It's very rare that we have 2 yeses next to each other. If that happens, it's usually a special quadratic, like maybe a difference of squares or something that has 2 of the same solution. So can it happen? Yes, but it's just more rare. So I just want you to know that that pattern means something. Keep an eye out for it. All right, as always, make sure to check Google Classroom to see what the task is. Let me know if you have any questions or check out the Sabre Center schedule. And until next time, have a good one.